So, okay guys, we are going to do a quick review of the observational studies. Based on when it's done, we can classify that into cross-sectional, retrospective, and in the future for the prospective study. We have some exercise here. I'll give you 30 seconds to try to read it through and see what type of observational study this is. Okay, so first one, talking about the study, they went back in time to determine how those residents were involved. When you go back to time, that's going to be retrospective, right? Retrospective study. Okay. Second one, physicians, blah, 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 and they plan to study, okay, they plan to study those workers from now until 7 years into the future. So that's going to be in the future, right? And this is going to be typical prospective study. Okay, so this is pretty easy. Just need to see when they are collecting the data. If it's in the back, then it's retrospective. It's in the future, then prospective. In one time, that's going to be cross-sectional. Okay, so the next is just a summary of observational versus experiment. In the very end, we would like to talk about sampling methods that we can do. How can we collect the samples? We'll be talking about the popular sampling methods that we can be using quite a lot. Okay. The first time is called random sample, which is randomly you select individual ones. And these individual ones should have an equal chance to be selected. So those are considered to be random sample. Okay. I like to use a diagram to illustrate this. So that suppose you have a big population and you have so many individual subjects to be studied. Each one should have the same chance to be selected. And this one that you have picked is called a random sample. Sometimes we can pick a random sample of certain size. Okay. So then we just extend the idea a little bit more, a simple random sample of n subjects. So I'm going to do the same thing here. So you have a big population which has a lot of objects. And we just pick, say, every time we pick 4 or pick 5 or pick 10. Okay. This is called random sample of n subjects. Okay. But no matter what, those samples that you have picked should have equal chance to be selected. Some other sampling methods that we use quite often are systematic samples. This is very easily to be seen. A lot of times you number each subject and then selecting every case number of objects. Convenient sample, by using results that's very easy to get, such as your friends, your family members, anything that's convenient to you, to the researcher. Okay, and these two, the next two are very similar. One is called the simple cluster sample. One is called stratified sample. I'll give you 30 seconds to read the description of these two, and we will talk about how they are different. Okay, so when you're doing the first one, which is the simple cluster samples, you're using intact groups, the whole groups. Okay. If you're doing stratified samples, then you are dividing the population into groups, and then you take something from each group. Okay. So using samples from each group, while the cluster samples, you use the intact groups. Next slide talks about the difference between these two as a note. Okay. I like to using the diagrams to show this again. So first of all, suppose we have big population. Let's first look at the simple cluster sampling. So for a big population, we can have several different groups, right? Different groups. As for the certain simple cluster sampling, we just take one group and take all of the items from this group out. That's going to be the simple cluster sampling. Let's look at stratified. Stratified uses a sample of members from all the groups. So suppose this is population, and again we can put them into different groups. And what we do here for stratified sampling is we take sample from each group. So say the first sample from the second, and second sample from second group, third sample from third group, fourth, fifth, sixth, seventh. So we take sample from each groups and put them together, take all them out eventually. And this is called the stratified sampling. Okay? So you see the difference between these two? One is uses the entire group, one is using the sample of the groups. Okay? Now let's look at the exercise of the following 5 questions, excuse me. I'll give you 30 seconds. First of all, look at this page here, and we'll come back to talk about which sampling method they've used. Okay, so the first one, a student of the author collected measurements of arm length from her family members. Her family members is very convenient to her, so we should be using convenience sample. Right, convenience sample. Second one, the mail carriers of a large city are divided into 4 groups, and then according to whether they walk or ride on their routes. Then 10 are selected from each groups. Okay, 10 are selected from each groups. This goes back to 4 groups and 10 from each group. So that's a stratified. So this is going to be a stratified sample because you are doing sample from each group, right? Stratified sample. CDE, okay, another 30 seconds for you guys. Okay, C. Nursing supervisors are selected using random numbers. Random numbers. So random numbers, this is random sampling. Random sampling. Okay. In a large school district, all teachers from 2 buildings. All teachers from 2 buildings are interviewed to determine whether they believe the students have less homework to do now than previous years. All teachers from 2 buildings. Okay, that's going to be an entire cluster. So this be cluster sample. Okay, so since they used 2 buildings, entire 2 buildings teacher, this is going to be a typical cluster sample. The last one, every 7 customer. 7. This is definitely going to be systematic. Systematic sample because they're picking every 7. The last piece of our introduction to statistics is the errors that we can get from the samples. So they can be put into 2 kinds of errors. One is called sampling error, one is called non-sampling error. Okay. So sampling error is basically talk about from sample fluctuations, the difference between the actual sample results and the population results. Non-sampling error means it's basically the data is not correct. So sample data incorrectly corrected, analyzed, used a wrong sample, a bad sample, used a wrong method. Those will all cause different kinds of errors. Okay, so that is the end of our Chapter 1, Introduction to Statistics. You guys should move on to work on the exercise problems and let me know if you have any questions. Thank you.